Hi, today we're going to go ahead and discuss free body diagrams, or FBD for short. So let's go ahead and start by going back and reviewing what a vector is. A vector can be represented with an arrow. Has to have two different things. A vector shows magnitude, and it shows direction. So the magnitude is just how much, right? It's the number. And the direction, of course, is which way it's going. So a vector has magnitude and it has direction. That's why we can use an arrow to represent a vector. And so a couple of different things that can be represented with a vector are velocity, which you've seen, acceleration, and for today, what we're going to focus on are forces. So we're going to focus on forces today. So force vector, what we're going to be looking at. Force vectors. So what is a force? A force is simply a push or a pull. It's either a push or a pull. And so we can use arrows to represent that push or that pull. We're going to use a free body diagram, or an FBD for short. Free body diagram. So a free body diagram shows an object, a simple object, with all of the forces that act on that object. Okay? It's free of all of the background information, all of the background noise. Okay? It's simply the object with all of the forces acting on that said object. So if we want to look at a car or a person or something, sometimes the easiest way to do that is just use a simplified drawing. So in this case, let's take a look at a box. A box would represent something. Right? It could be a car, it could be anything. But all of the forces that act on this object represent that free body diagram. So let's say that we have a force of 5 newtons. So let me back up really quick. A force, yes, is a push or a pull, and it's represented with the units newtons, right? Or N for short. So newtons are the unit for force, are the units for force. So when I look at my object and we say that there's a force of 5 newtons applied to it, notice we have an arrow. This arrow represents the direction that the force is, right? It's moving to the right, and we know that it's representative of 5 newtons. Okay. If you were to take an apple and you were to hold that apple in your hand, an average size apple, the weight that you feel in your hand is equivalent to about 1 newton. Okay. So 5 newtons is like the weight of 5 apples. So if we take an object and we have a vector, a force vector, okay, we can see it's 5 newtons to the right. This is our free body diagram. It shows all of the forces acting on that object. Okay. So, free body diagram. Now, could you have more than one force acting on an object? And the answer is yes, you can. So let's take a look at different scenarios here. let's take a look at something like this. Let's say that you have an object, whatever it is. Let's say that you have a force of 5 newtons pushing this object to the right. And let's say that you have another 5 newtons pushing this object to the right. If the forces are in the same direction, we're going to take those and we're going to add these forces together. So if we add these together, the sum, sigma here, the sum of all of the forces is equal to 10 newtons. Or another way to say it is the net force is equal to 10 newtons. So the sum of all your forces, or the net force, is equal to 10 newtons. If they're in the same direction, we're going to go ahead and add those forces together. Now, you can have a situation where you have your object. Let's say that you have 5 newtons to the right, and let's say that we have, 5 newtons to the left. If you have your forces, here, sorry about that. If your forces are in opposite directions, we are going to subtract. So if you take 5 newtons to the left, 5 newtons to the right, we're going to subtract because they're in opposite directions. So if we subtract, we're going to get that the sum of all of the forces is equal to 0. Or you can say the net force is equal to 0. The sum of all the forces, right, that's that sigma, means the sum of all the forces is equal to 0, or the net force, the total force after adding or subtracting. Now, we could have a third situation. Let's say that you have your object, and let's say that that object is being pushed to the right at 3 newtons. And let's say that you have a force that's pushing in an upward direction at 4 newtons. So we have 3 newtons to the right, and we have 4 newtons pushing in an upward direction. Now this one is different because they're not in the same direction, so we can't add, and they're not in opposite directions, so we can't subtract. But remember, with vectors, we can move them around, and we can put them head to tail. What that means is vectors can be moved as long as they go from head to tail, and it doesn't matter which one goes first. So for example, I could start with 4 newtons. So 4 newtons in an upward direction, and I could take this one and place it here. And so you have your first vector. This is where the starting point. Notice right here, they are head to tail. So the head of this arrow is the tail of this arrow, the tail end of this arrow. This was the start. Where did it end up? It ended up here. So this is what's known as my resultant vector. It's the result of these two here. I've created, or I have, a right triangle. So the resultant vector, or the sum of all forces, is equal to 5 newtons, or the net force is equal to 5 newtons. Where did we get 5 newtons from? I'm going to use Pythagorean theorem to solve for the hypotenuse of this right triangle that's created. I knew that it was a 3, 4, 5 right triangle, a special right triangle, so that's why I knew it was 5. So if I go back to this idea that it doesn't matter which one I start with, let's say that I start with 3 newtons first instead. So if I start with the vector, the force vector of 3 newtons, here's my first one, right? I start here, I place my arrow, my vector. Next, I'm going to place the 4 newton vector here. So when I place the 4 newton vector here, notice they're head to tail. I started with the 3 to the right first, but look, this is where I started, this is where I ended up. So this is my resultant vector. Notice that the resultant vector is in the same direction, regardless of whether if I started with the 4 newtons first and then added the 3 newton vector, or if I started with the 3 newton vector and then added the 4 newton vector. My resultant vector direction is the same, and you'll notice this is a 3, 4, 5 special right triangle. So the sum of my forces ends up being 5 newtons. What direction is it? It's north, right? Because we're going to consider the top of the page north. To the right is east. To the bottom of the page is south. West is going to be to the left. Right? So these are my cardinal directions. So if I look, both of these are pointing northeast. So the sum of my force would be 5 newtons northeast. That would be the answer for the net force, or the sum of all my forces. It's 5 newtons northeast. We're just using Pythagorean theorem here. Use Pythagorean theorem whenever you have force vectors that are right angles to each other. You're going to add if your force vectors are in the same direction, and you're going to subtract if your force vectors are in opposite directions. These are your free body diagrams. Okay? So let's take a look at a free body diagram, a real world example of a free body diagram. Let's say that you have a table, and on this table you have a book. So a book is easy to draw. Here's our book. Right? Here's our book. That book has a weight. That weight is the downward force that's applied to the table. So the weight of this book is in a downward direction. Now, why does the book not fall down continually, like through the table? It's because the force applies, the table applies a force to the book in an upward direction. Let's say that the weight is 5 newtons. Let's say the upward force is 5 newtons. Then we could say that the sum of all the forces is equal to 0. How do we know it's 0? Because they're in opposite directions, and so we're going to subtract. We can say the net force is 0. So that's what a free body diagram is. That's what happens when you look at your forces. You can say whether you add, subtract, or use Pythagorean theorem. It depends on what direction they're pointing. Okay, we'll delve deeper into this with a second video that I do when we start looking at balanced and unbalanced forces.